quickly, and then there's a few high notes that I want to spend a little bit more time emphasizing. A lot of the stuff with the polynomials, there are some tricks that kind of help us. We're still applying those operations with the exponents, using those exponent properties for a lot of it, but now we're just kind of expanding on that. There's some special products that we're going to do that are really, really important. We'll come back around when we do factoring. Okay? So it's important to kind of make the connection with those special products when we get there. So to start multiplying, we got a monomial times a monomial. That's just our laws of exponents. Okay, that's what we've been doing. Nothing different there. We can rearrange this all into the orders with the like basis, and then we use our properties of exponents to simplify. 8 times 9. 72. K to the third times K. K to the fourth. Y times Y. Easy peasy, right? Now we're adding in binomials and trinomials. We're adding in multiplication with our polynomials beyond the first term. It's just a lot of distributed property. And then some combining like terms depending on how big our polynomials are. So I've got negative 2r times 9r, and I've got negative 2r times negative 5. So I'm doing both of those operations. So negative 2r times 9r and negative 2r times negative 5. Okay? Multiply both of those sets. Negative 2r times 9r gives me what? Good. Negative 2r times negative 5. 10r. Okay, so that minus 5 becomes a negative 5, and then you do the multiplication that's going to take care of that, that sign change in there from subtraction to addition. Yeah, we can't combine like terms because they're not like terms. So that's as far as we can go. So binomial times binomial. Every term in the first will be multiplied by every term in the second. Okay, so first times first, first times second, second times first, second times second. So I've got 2k times 3k gives me what? 6k squared. Good. 2k times 2m. Say that again? 4. Thank you. I couldn't understand the coefficient. 4km. Negative 5m times 3k. And then negative 5m times 2m. M squared. Okay? Can I simplify that further? Yeah, what can I do? Combine those like terms. So there's nothing with the k squared minus 11km minus 10m squared. Alright? Easy peasy? Questions, comments, concerns?
Should you put the square together?
So it gets weird with multiple variables and multiple powers. The convention with this is a little wonky. So in general, when you've got multiple variables, just leave it in that order from that multiplication and just combine like terms and you should be fine. Okay. Alright. Find each product. I'm going to skip the first one because it's very similar to the last one. I'm going to go straight to B. Alright, because now I've got this 4-term polynomial times the binomial. Same process, same idea. I just have to do it with every single term. So I'm going to have a lot more multiplication going on. So every term in that first binomial or first polynomial will be multiplied by both terms in the binomial. Alright, so let me start with the first set. 5a cubed times 2a. 10a to the fourth. 5a cubed times negative 5. Negative 25a cubed. Okay, so that's the first set. Second set. Now I got the negative 6a squared times both of those. Next.
Negative 30.
Positive 30. A squared. Okay? Second set. Now third set. I was looking at the wrong thing and I got very confused very quickly. Third set. And negative 6a and positive 15.
Do you have to do it that way? Because my brain wants to go.
That's fine.
And then you only need to find.
That's fine. Yeah. As the important thing is that every single term here gets multiplied by both of those. As long as that happens, you're good. You could even take this, move to the front, and do 2a times 5.
That's easy.
Yeah.
38 is that 38?
30a squared. 30a squared.
You need to combine it like terms and all that.
And all that.
Yep.
Okay? So, give me some like terms. Gives me what? That's a 4a squared. And we got it in order from descending powers. Fun, right? Of all the things we'll do, this is, I wouldn't say easiest, but it's definitely on the easier side, and it's, I think, somewhat satisfying. It's got an odd satisfaction to it. Alright, so next thing we're going to cover is what we call special products. So with a lot of these, you can always default back to distributive property. Okay? If you don't remember the special products, that's fine. You can always default back to distributive property. That'll get you the answer with your multiplication. However, it's really important to kind of be aware of these and to make those connections, because when we move into factoring, you need to be able to kind of go back. All right? These special products lead us into special case factoring. Notice if I have two terms that are identical in binomials, but I'm adding one and I'm subtracting the other, that gives me a difference of squares, which is a special case factoring that we're going to be doing later. So knowing that connection, being able to go back and forth is really important, because you can't factor a difference of squares unless you know that it gives you the product of a sum and difference. Okay, so you need to be able to go back and forth between the two. So, if I do distributive property, we'll see why we get the pattern that we do. M squared, would help it in the right order. M squared minus 5m plus 5m minus 25. What happens with those middle terms? They cancel out. Negative 5, positive 5 makes those go away. M squared minus 25. Negative 5 plus 5 is what? So then, using that pattern, my first term squared is m squared. My second term squared is 25, and it's a difference. So noticing that difference of squares, or the sum and difference of two terms, will allow you to just kind of speed up this process of multiplying. Okay? So if I look at that, I look at my first term. What's the square of my first term? What's the square of my second term? 16 y squared. And then what do I put in the middle? Minus. It's always going to be minus.
Even if it's switched.
Yep. It's always going to be minus. If one's plus and one's minus and they're the same term, it's always going to be subtraction. Okay? Because if you look back at our pattern, our formula, two things being added, the same two things being subtracted gives me them squared, subtracted. That's how we get the difference of squares. Okay? If we have multiple polynomials and you see that sum and product, or that sum and difference, then do that part first before you distribute, so that way you can use the pattern. Y squared minus 49, and then multiply by your other polynomial. 4y to the fourth.
I'm not asking. I was like, give me some credit. No.
Actually, it's 1 less than 50. Do 50 times 4 and then subtract 4. That's all I know. Yeah. But I've been doing this. We're going to have a chat. Our other special case that we're going to focus on is the square of a binomial. So if I have the same terms, okay, added or subtracted, but it's squared. I've got a binomial squared. Remember, when you square something, it's repeated multiplication, right? So x plus y squared is x plus y times x plus y. So again, you could default to distributive property, but there's a pattern that follows these, which again will help later down the line when we're doing factoring. Being able to take something that fits this, which we call a perfect square trinomial. We got a perfect square trinomial, being able to factor it into a square binomial. All right? Here's what I want you to notice with this pattern. All right, I'm going to break this down. Okay? So I've got x and y. The first one is my first term squared. First term squared. The next is going to be double the product of the two terms. Double product of both terms. So we multiply whatever our two terms are and then double it. Okay? Multiply them together, double it. That gives us our middle. And then the last one is going to be the second term squared. Second term squared. Squared. There we go. Okay? Now, I have different formulas for one is plus and one is minus. So pay attention to the differences. First and foremost, the second term is always addition. Or the second sign. Always going to be addition. The first one is going to match with your binomial. So the first sign will match your binomial. The second one is always plus. So you can look at anything with a binomial squared and take the first term squared, the second term squared. That gives you your first and last term. Multiply them, double it. That gives you your middle term. Man, you guys are just killing it today. So I'm going to do distributive on the first one so you see why the pattern ends up being the way that it is. I don't know why that is still on. Try that again. There we go. Okay. So t plus 9 times t plus 9. T squared, t plus 9, or sorry, t times 9. 9 times t, and 81. I end up with the same term twice. That's why I multiply and double. When you do that multiplication, you end up with the same term twice, which is why we multiply and double. Square the first term, square the last term, multiply and double. So let's do that here. What's the square of my first term? Close. 4m squared. Okay. What's the square of my second term? So I'll put that over here. All right. Multiply them together and then double it. So 2m times 5 is 10m. Double it. 20m. 20m. First one's going to match. Second one's always plus. Do it again.
Okay. And then you got 4. And then you have to multiply it. We
3, how did I get to 12? 3 times 2 is 6, double it to get 12. And there it is. First sign matches the binomial, second sign is always plus. Questions, comments, concerns? All right. What do I have here? It's math class. Yes. I've got a 4th power. Okay. Fourth power squared squared. That's that product rule, right? Or the power rule. Multiply a variable by, or exponent by an exponent, you get that power rule. So we can rewrite a 4th power as something squared squared. So now I can use my square binomial rule to save myself a lot of distributive property. Cuts the work in half. Instead of writing this out as instead of writing out the full expansion, distribute, I can save myself some time with that pattern. So x plus 2 squared is going to be what? X squared plus 4x plus 4. Okay, and it's squared. Now, I cannot use the binomial squared with a trinomial squared. Okay, the pattern doesn't follow because now it's something different. So we just have to do distributive property. So we need to write it out twice. So I'll get rid of that squared. And we're going to do that distributive property.
That's a lot.
It is. I mean, it's 10 multiplications. So 4x to the third, 4x to the third. Nothing with x to the fourth, so that stays. Okay, so done with that, done with that, done with that. X squareds to get what? There you go. And then nothing to combine with the 16. It's a lot. It's not hard. It's a lot. Take it step by step. Don't overthink it. Don't freak out. Just do it. And keep going until you're done. Alright, last thing I want to talk about is functions. I will tell you right now, I saw so many functions on your test that made me want to hit my head against the table. I emphasized many times that those are not the same thing. F of g of x is not f times g. Yet I saw that a lot. Like a lot. Composition and multiplication are two separate operations. They do two completely different. To be aware of the notation and separate those two from each other. They are separate things. We are not doing composition. This is multiplication. Fg. F times g. So we multiply those. We look at f. We look at g. We write out our binomials or whatever our polynomials are. They could be monomials, trinomials, fourth degree, or four terms. Okay? Whatever it is. We multiply. Distributive property. 6x squared. Keep going. Good. Plus 2x minus 5. Combine your like terms. 6x squared minus 13x minus 5. That is f times g of x. Okay, that's that combination, f times g of x. Now, if I have f times g of 2, what do I do with that 2? Plug it in. So, f times g of 2 is going to be 6, 2 squared minus 13 times 2 minus 5. We plug it into that multiplication. Now, I want to make another special note because that's way more than I like to admit. I saw a whole lot of 6 being multiplied by 2 before it gets squared. And that makes me sad. Don't do that. Order of operations says we do what first? Exponents. Always do your exponents first. So we do 2 squared to get 4. Yeah, but not everyone actually went ahead and bought the calculator that's required for the class. So there's that issue. Girl, you're a Montford, like. So then you can go buy a calculator. 6 times 4.
24.
24. 13 times 2. Minus 5. There you go. Perfect. Magic numbers. I don't know. Cool. My last 2 makeups are happening today, and I can do them back tomorrow. The grades are in Canvas already. All right. Questions, comments, concerns, queries, or conundrums?
I have an unrelated question.
Okay.
What is our...
About 50 questions, multiple choice.
Oh.
The test on this is multiple
Yes.
choice.
No, that's not.
What is multiple choice?
This semester.
What?